Okay, this is episode 3, solutions of equations involving sine and cosine. So for question 2 here, the question is asking us to find the value of x within this domain. First we're going to begin by addressing what theta is. Let's make x equals theta, and now let's address what our domain is. So we've got no transformations, it's just sine x, so our domain just remains 0 is greater than or equal to 0 and less than or equal to 2 pi. Now sine x, okay, so let x equal theta. Sine theta equals negative root 3 on 2. The reference angle here is pi on 3. Pi on 3 is negative root 3 on 2 is negative, meaning we need to find the quadrants in which pi on 3, the reference angle here, is negative between 0 and 2 pi. So theta equals, let's picture this out, sine pi on 3 is negative in these two quadrants, and we need to find all the solutions from 0 to 2 pi. 0 to 2 pi. Okay, theta equals 4 pi on 3 and 5 pi on 3. That's it, first question done. Sine 2x. Let's make 2x, let 2x equal theta. Sine theta. Okay, let's first address what the domain is. So we've got 2x here, 0, x is greater than or equal to 0, less than or equal to 2 pi. Now we need to adjust this domain. Over here we've got a dilation by a factor of 2, so we're going to apply this dilation to each component in this domain to adjust it, to expand it. So 0 is less than or equal to 2x, which is less than or equal to 4 pi. Zero is less than or equal to theta, which is less than or equal to 4 pi. Now our reference angle here, okay, sine theta equals negative root 3 on 2. Again, our reference angle is pi on 3, negative pi on 3 when it's negative, pi on 3, sine pi on 3 is negative in the third and fourth quadrant, and we need to first find the solutions, all the solutions from 0 to 4 pi. Let's go. Theta equals 4 pi on 3, 5 pi on 3. Now once we've got these solutions, our domain is 4 pi, so we're simply just going to add 2 pi to each of these solutions. 4 pi on 3 plus 2 pi. And lastly, 5 pi on 3 plus 2 pi. Theta equals 4 pi on 3, 4 pi on 3, 5 pi on 3, 4 pi on 3 plus, let's break this up, 6 pi on 3, 5 pi on 3 plus 6 pi on 3. Theta equals 4 pi on 3, 4 pi on 3, 5 pi on 3, 10 pi on 3, and 11 pi on 3. Now okay, we know theta is 2x, so we're going to put 2x back here. 2x equals 4 pi on 3, 5 pi on 3, 10 pi on 3, and 11 pi on 3. Now because our aim in this question is to find the value of x, we're trying to find the solutions of x, we're going to divide all these solutions by 2. So x equals 4 pi on 6, 5 pi on 6, 10 pi on 6, and 11 pi on 6. Now make sure to simplify this. Let's simplify this real quick. 2, 3, can't do this one. 5, 3. X equals 2 pi on 3, 5 pi on 6, 5 pi on 3, and 11 pi on 6. Now one last piece of working is, because x, let's just write the domain again, because x is an element of 0, 2 pi. Okay, next question. 2 cosine 2x equals -1. Let's rearrange this. Cosine 2x equals -1/2. Let 2x equal theta. Now let's extend the domain. The domain given is 0, 2 pi. So 0 is less than or equal to x, and x is less than or equal to 2 pi. We've got a dilation of 2 here, so we're going to apply this dilation to every element here. Again, 0 is less than or equal to 2x, which is less than or equal to 4 pi. Now cos theta equals -1/2. So our reference angle is pi on 3, and cosine pi on 3 is negative in the second and third quadrant. So it's theta. Okay, now let's find all the solutions of theta within this given domain. Theta equals to 2 pi on 3, 4 pi on 3. We're going to add 2 pi now to both of these solutions. 2 pi on 3 plus 6 pi on 3, 4 pi on 3 plus 6 pi on 3. Theta equals 2 pi on 3, 4 pi on 3, 8 pi on 3, and 10 pi on 3. Now let's sub in the value for theta back in. 2x equals 2 pi on 3, 4 pi on 3, 8 pi on 3, and 10 pi on 3. Now let's just divide all these solutions by 2 to now find x. X equals 2 pi on 6, 4 pi on 6, 8 pi on 6, 10 pi on 6. Let's simplify this answer now. 3, 1, 3, 2, 3, 4, 3, 5. X equals pi on 3, 2 pi on 3, 4 pi on 3, 5 pi on 3. Now before we go any further, I want to make one thing clear, and in case you guys haven't seen the previous videos, all these angles, all these reference angles, you see me do this so quickly and you might be confused. So the way we do this is we derive all these angles. We can derive cosine, sine, tan, pi on 3, pi on 6, and pi on 4 using special triangles. Let me draw them out for you all. Pi on 3, pi on 6, root 3, 1, 2. This is our first special triangle. This is where we can derive all these values as I've said earlier. And the second special triangle is pi on 4, pi on 4, 1, root 2. Remember all of these. If you want to make your life 1000% easier, remember these two special triangles. Let's move on. Okay, sine x plus pi on 3 equals negative 1/2. Let x plus pi on 3 equal theta. Now let's adjust our domain. The original domain is 0 is less than or equal to x, which is less than or equal to 2 pi. Now over here we have a translation of pi on 3 units to the left. And so our translation of pi on 3 units to the left means we're just simply going to apply this transformation to all of these elements. Let's do this. Pi on 3. We're going to write the implies arrow. Correct me if I'm wrong. Okay. This implies pi on 3 greater than, less than or equal to x plus pi on 3 is less than or equal to 2 pi plus pi on 3. This implies pi on 3 is less than or equal to theta, which is less than or equal to 2 pi plus pi on 3. Okay, our reference angle sine theta equals negative 1/2, which makes our reference angle pi on 6. Pi on 6, sine pi on 6 is negative in the third and the fourth quadrant, and we want to find the solutions from pi on 3 to 2 pi on 3. Let's get started. Theta equals 7 pi on 6, and 11 pi on 6. We can't go any further because that's not a solution, and yep, these are our two solutions. Theta, now let's sub in x plus pi on 3. X plus pi on 3 equals 7 pi on 6 and 11 pi on 6. To make this easier to solve, we're just going to make this x plus 2 pi on 6 equals 7 pi on 6 and 11 pi on 6. And then we're just going to subtract 2 pi on 6 from both of these solutions to find x. X equals 5 pi on 6 and 9 pi on 6. Let's simplify the solution here. X equals 5 pi on 6 and 3 pi on 2, as x is an element of 0 and 2 pi. Next question. 2 cosine 2x plus pi on 3. Alright, cosine 2x plus 2 pi on 3, let's make this easier for ourselves, equals negative 1/2. Let 2x plus 2 pi on 3 equal theta. Now let's adjust our domain in accordance to these transformations. We've got a translation of pi on 3 to the left and a dilation by a factor of 2. 0 is less than or equal to x, which is less than or equal to 2 pi. Let's first apply the 2x. Dilation 0, this implies 0 is less than or equal to 2x, which is less than or equal to 4 pi. Then we add 2 pi on 3. 2 pi, this implies 2 pi on 3 is less than or equal to 2x plus 2 pi on 3, which is less than or equal to 4 pi plus 2 pi on 3. This implies 2 pi on 3 is less than or equal to theta, which is less than or equal to 4 pi plus 2 pi on 3. Now our reference angle, okay, cos theta equals negative 1/2, which makes our reference angle pi on 3, and pi on 3 is negative. Cosine pi on 3 is negative in the second and third quadrant, and we want to find all the solutions where cosine pi on 3 is negative from 2 pi on 3 to 4 pi plus 2 pi on 3. Theta equals 2 pi on 3, 4 pi on 3, 2 pi on 3, plus 2 pi, 4 pi on 3, plus 2 pi, and 4 pi plus 2 pi on 3. Theta equals 2 pi on 3, 4 pi on 3, 6 or 8 pi on 3, 6 or 10 pi on 3, and 4, 12, 14 pi on 3. Now let's sub back in 2x plus 2 pi on 3, 2x plus 2 pi on 3 equals 2 pi on 3, 4 pi on 3, 8 pi on 3, 10 pi on 3, and 14 pi on 3. Let's subtract 2 pi on 3. 2x equals 0, 2 pi on 3, 6 pi on 3, 8 pi on 3, and 12 pi on 3. Let's divide all these solutions by 2 now. X equals 0, 2 pi on 6, 6 pi on 6, 8 pi on 6, 12 pi on 6. Let's simplify our solutions now. X equals 0, 3, 1 pi on 3, pi, 3, 4, 4 pi on 3, and 2 pi, as x is an element of 0 to pi. 2 sine 2x plus pi on 3 equals negative root 3 sine 2x plus plus pi on 3 equals negative root 3 on 2. Let 2x plus pi on 3 equal theta. Let's adjust our domain. We've got a dilation of a factor of 2 in the y-axis and a translation of pi on 3 units to the left. Let's apply this to our domain. 0 is less than or equal to x, which is less than or equal to 2 pi. Let's apply the 2x. Dilation 0. This implies 0 is less than or equal to 2x, which is less than or equal to 4 pi. Now we apply the translation. Set pi on 3. This implies pi on 3 is less than or equal to 2x plus pi on 3, which is less than or equal to 4 pi plus pi on 3. This implies pi on 3 is less than or equal to theta, which is less than or equal to 4 pi plus pi on 3. Sine theta, okay, sine theta equals negative root 3 on 2. This makes our reference angle pi on 3. And sine pi on 3 is negative in the third and fourth quadrant, and we need to find all the solutions where this occurs between pi on 3 and 4 pi plus pi on 3. Theta equals 4 pi on 3, 5 pi on 3, 4 pi on 3, plus 2 pi, which is 6 pi on 3, to make the calculations easier. Then 5 pi on 3, plus 6 pi on 3. Okay, we've got this. Okay, 1 pi, 2 pi. 1 pi, 2 pi, 3 pi, 4 pi. We only have 4 solutions, which we have here. So theta equals 4 pi on 3, 5 pi on 3, 10 pi on 3, and 11 pi on 3. Now let's sub in our theta value, which is 2x plus pi on 3. 2x plus pi on 3 equals 4 pi on 3, 5 pi on 3, 10 pi on 3, and 11 pi on 3. 2x equals 3 pi on 3, 4 pi on 3, 9 pi on 3, and 10 pi on 3. Now let's divide all these solutions by 2. X equals 3 pi on 6, 4 pi on 6, 9 pi on 6, 10 pi on 6. Time to simplify. X equals 2, 1, 3, 2, 2, 3, 3, 5. X equals pi on 2, 2 pi on 3, 3 pi on 2, and 5 pi on 3, as x is an element of 0 to pi. Now the next question. Okay, solve each of the following for x. Now we're doing the same thing as the previous question, except we are now given a different domain, negative pi and pi. What this means is our current domain, something like this. X is within pi, or it's between negative pi. Let's get started. Sine x equals negative 1/2. Our domain is the same, which means negative pi is less than or equal to x, which is less than or equal to pi. Now our reference angle, so sine x equals negative 1/2. Let's say this again. So x must equal to, within this range, sine x, the reference angle for sine x equals negative 1/2. Reference angle is pi on 6, and sine pi on 6 is negative in the third and fourth quadrant. Let's find the solutions. X is going this direction. From 0 to pi, there are no solutions because sine is positive. Negative pi on 6, and negative 5 pi on 6. Negative 5 pi on 6. Sine 3x. Okay. So we know that sine, let's first start off with this. Sine is always negative when we are at these 2 points. So these are our reference angles. Our reference angles are 0 and pi. Alright, let's define our domain. So 0 is less than or equal to x, which is, negative pi is less than or equal to x, which is less than or equal to pi. Now we have a dilation of 3, so we're going to apply this to all of these elements. To get 3x, negative 3 pi is less than or equal to 3x implies 3x, which is less than or equal to 3 pi. This implies negative 3 pi is less than or equal to theta, which is less than or equal to 3 pi. Let's one mistake I made here, sorry guys. Sine 3x, let's just say 3x, let 3x equal theta. Okay, let's continue. Now, our reference angles we've established earlier, 0 or pi, and we need to find all the solutions from negative 3 pi to 3 pi. Sketch this out. Theta equals pi, 2 pi, okay wait, yep, pi, 2 pi and 3 pi, pi, 2 pi, 3 pi. In the other direction, negative pi, negative 2 pi, negative 3 pi. Negative pi, negative 2 pi, negative 3 pi. Now one thing you don't want to do like I'm doing is to have the order of all of these solutions in non-chronological order. In the exam, always make sure you write these solutions in chronological order from smallest to largest, okay? Let's continue. Now that we've got our solutions, let's sub in 3x. 3x equals pi, 2 pi, 3 pi, negative pi, negative 2 pi, and negative 3 pi. Let's divide all these by 3. X equals pi on 3, 2 pi on 3, pi, negative pi on 3, negative 2 pi on 3, and negative pi. Let's just write this in proper order. X equals negative pi, negative 2 pi on 3, negative pi on 3, pi on 3, 2 pi on 3, and pi, as x is an element of negative pi and pi. Next question, cosine x over 2 equals 1. The dilation here is by 1/2. Cosine equals, okay, cosine is 1 when we are at the origin, right? So this is our reference angle. Our reference angle is 0 degrees or 2 pi. 2 pi or 0. Those are our two reference angles. Cosine x, okay, x over 2 equals 1. Let's establish our domain. Negative pi less than or equal to x, which is less than or equal to pi. Dilation of 2, so negative pi on 2 is less than or equal to x on 2, which is less than or equal to pi on 2. Now cosine is 1 here, so wait, let me just finish this real quick. Theta is less than or equal to pi on 2. Now theta, okay, theta, starting at negative pi on 2, 0 to negative pi on 2, and pi on 2. Theta is 0. There are no solutions. Okay, moving on. D sine x minus pi on 6 equals negative 1/2. So let's identify our translations. We've got a translation to the right, the positive side of the x-axis by pi on 6. Let's establish x minus pi on 6 is theta. Let's adjust our domain now. Negative pi is less than or equal to x, which is less than or equal to pi. We've got a translation negative pi on 6. Let's apply this here. Negative pi minus pi on 6 is less than or equal to x minus pi on 6, which is less than or equal to pi minus pi on 6. Sine theta equals negative 1/2, which makes our reference angle pi on 6. And sine pi on 6 is negative in the third and fourth quadrants. So let's find the solutions. Theta, all within this domain. Right. Theta equals, okay, let's think about this. We've got this solution, negative pi on 6, negative 5 pi on 6, then another negative pi on 6, that can't be a solution. Pi minus pi on 6, okay. Pi minus pi on 6, it ends here, so these are our two solutions. Let's sub in x minus pi on 6. X minus pi on 6 equals negative pi on 6, negative 5 pi on 6. Add pi on 6 to both sides. X equals 0, negative 4 pi on 6. X equals 0, negative 2 pi on 3. Okay, one last question. 2 cosine 2x plus pi on 6. Let's expand this to make this easier for us. Let's move this to here. Cosine, going to expand this here. Cosine 2x plus 2 pi on 6 is the same as pi on 3. So 2x plus pi on 3 equals negative 1/2. Let 2x plus pi on 3 equal theta. So just our domain. So the domain we originally have as negative pi is less than or equal to x, which is less than or equal to pi. Let's apply this 2x dilation. Negative 2 pi is less than or equal to 2x, which is less than or equal to 2 pi. Add pi on 3. Negative 2 pi plus pi on 3 is less than or equal to 2x plus pi on 3 plus pi on 3, which is less than or equal to 2 pi plus pi on 3. This implies negative 2 pi plus pi on 3 is less than or equal to theta, which is less than or equal to 2 pi plus pi on 3. Cosine theta, okay, cosine theta equals negative 1/2, which makes our reference angle is pi on 3, and cosine pi on 3 is negative in the second and third quadrants. So let's find the solutions. Theta, okay, let's go in the positive direction. 2 pi is pi, 2 pi plus pi on 3, back here. Okay, first we've got 2 pi on 3, 2 pi on 3, 4 pi on 3. Once we make the full rotation, 2 pi plus pi on 3, normal solutions. Okay, let me redraw this. Now let's go in the opposite direction. Negative 2 pi. Okay, negative 2 pi is negative pi, negative 2 pi, plus pi on 3, which ends here. So our two angles are here, so negative 2 pi on 3, negative 4 pi on 3, and those are our solutions. Let's sub in 2x plus pi on 3, 2x plus pi on 3 equals 2 pi on 3, 4 pi on 3, negative 2 pi on 3, negative 4 pi on 3. Let's subtract pi on 3, 2x equals pi on 3, 3 pi on 3, negative 3 pi on 3, negative 5 pi on 3. Let's divide the solutions by 2. X equals pi on 6, 3 pi on 6, negative 3 pi on 6, and negative 5 pi on 6. Let's simplify these solutions. X equals pi on 6, pi on 2, negative pi on 2, and negative 5 pi on 6. Let me just write this in the correct chronological order as we'd like in the exam. X equals negative 5 pi on 6, negative pi on 2, pi on 6, and pi on 2, as x is an element of negative pi and pi.